When Maxwell described the electromagnetic phenomena, he actually had 20 equations that related the fields and potentials. And they were very complicated to use. And so in the late 1800s, a man named Oliver Heaviside, he was an amateur engineer. He was able to reduce them to 4 equations to describe the phenomena. So the first that we have is Gauss's law. So that's the surface integral of the electric field with the dot product of the differential area, and that's equal to Q enclosed over epsilon naught, and we refer to this as Gauss's law. And it's obtained using the divergence theorem. The second one is also using the divergence theorem. It's the law with the magnetic field dot differential area vector, and that equals 0, and this is part of Gauss's law also, using the divergence theorem. And all of this is saying is that if I have some charge surrounded by a surface, this charge has electric field lines that exit this surface, and this quantity of electric field lines through this area, this dot product, is equal to some constant that is the Q enclosed divided by epsilon naught. Now if we look at it for a magnet, remembering that the magnetic field leaves the North Pole and goes to the South Pole, then if I draw a box around this magnet, and it's a three-dimensional box, could be any shape, but we'll just say a box for the moment, then all of the magnetic field lines that leave the North Pole are going to come back in and enter through the South Pole, and they're all going to go around this circle. And so the field does not diverge, it curls back on itself. So these are the two laws that use the divergence theorem when they're associated with Gauss. Now the next is the electric field, the line integral of the electric field dot differential length is equal to negative d phi of the magnetic field over dt, and this is Faraday's law. And then we have Ampere's law, magnetic field dot differential length is equal to mu naught times I enclosed plus mu naught epsilon naught times the change in the electric field with respect to time. And this is Ampere's law. And these are gotten by Stokes' theorem. So our next task is using these laws to be able to come up with an explanation of what is happening during this interaction between the electric and the magnetic fields.